Okay, well, welcome back to the second exam video. And in this particular video, we're going to look at solving quadratic equations. And one thing that I want to just start off by is reminding you that you have to remember this flow chart, this standard form. You have to be able to recognize each of these as well. Standard form, and then you write that in factored form. And then you want to solve for your zeros. And the flowchart goes both ways, actually. You can actually start with zeros and work your way back up. So just remember that. Zeros are roots. I'm going to put double arrows because this is two-way. It's a two-way thing. So let's take a look at this. All right, well, first of all, it's not quite yet in standard form, but as I look at this, I'm inspecting it first. I'm noticing that there is no linear term. In other words, there's a quadratic term, it's squared, but there is no single k. So when that's the case, we can solve it by isolating, just like a linear equation. And when I do, that strikes out, and I get k squared is equal to a -2. And as I'm solving now for k, I want to take the square root of both sides, and k is going to equal, and this is going to give me two answers, remember, plus and minus. This is imaginary. What do? Well, we take out the negative and we replace it with an I. So your final answer is plus and minus I times the square root of 2. Next, and this is, boy, this one's getting a lot of you. It's a very classic and common mistake. As I inspect this, I need to look at this flow chart. And where is it in the flow chart? Well, it's already factored. Don't try to pull it back up to standard form. That's what many of you are doing, is you're factoring, or you're distributing that p back in, and you're going in the wrong direction. So you want to go to zeros. So it's there. This is the easy kind, and some of you are making it more difficult. The zero product property states if you multiply two numbers together and the answer is 0, one of these two numbers or factors has to be equal to 0. So here you have p is going to equal 0. Or p minus 5 is going to equal 0. This one's already factored, so that's already one of the zeros. But when I solve for this one, I'm going to add the 5 over to the other side. So my two zeros are 0 and 5. Okay, number 11. It's definitely not in factored form, but it's not even in standard form. With standard form, ladies and gentlemen, we need to make sure that we pull the constant over and set it equal to 0. Now this looks like we can factor it into two binomials. If not, we'll have to use quadratic formula. But let's just see. We know that these first two can be n and n to get that n squared. We want the last two numbers to multiply out to equal -56, but they also have to add up to a -1. Easy, 7 and 8. To get the correct signs, we're going to have a -7, or excuse me, -8 and +7. So I can put a +7, -8. I'm not done because the question says to solve it. So now we've got it here in factored form. I can now find the zeros by setting each of these equal to 0. So I think we can do these mentally. What number plus 7 is equal to 0? We know that's going to equal -7. And what number minus 8 is going to equal 0? And we know that's going to equal +8. All right, let's move on to question number 12. All right, number 12. As I look at this, I see a more difficult question because my leading coefficient is 5. This is where you have to multiply a times c. And then let's just do that. Are there factors of -30 that will add up to a -3? Well, I have 6 and 5. That one doesn't work. I have 10 and 3. That one doesn't work. I have 15 and 2. That one doesn't work. If you can't find a combination, then guess what? It's time to pull out the quadratic formula. So in this case, there was not an option. So we're going to use quadratic formula. And so we have to define a, b, and c. A is going to equal 5. B is equal to -3. And c is equal to -6. Now, Again, I had to inspect it and make sure it was set equal to 0. And then I'm going to plug it into the negative b, plus and minus. You guys have to memorize this. Plus and minus the square root of b squared minus 4ac. And that's all over 2a. So let's plug these players in. When I plug in a negative b, well, something that's already been negative and I'm going to negate it again becomes positive. So it's going to be 3 plus and minus. Now let's do this one in our heads. What's negative 3 quantity squared? Yep, 9. Minus 4 times 5 times negative 6. Let's pull this over. And then this is going to be all over 2 times 5, which is 10. Okay, so now what we want to do is clean up what's underneath this radical. As I look at that, I got to watch my signs here. I have 2 negatives. So when I have 2 negatives, that's actually going to convert to a positive. 20 times 6 is 120. And when I add 9 to it, I get 129. And yes, you are hearing the star train in the background. Lovely. All right, this is actually 2 answers, and I could say X. Yeah, you can see what I live with now, folks. It doesn't come through very often, but when it does, it really does a number on the noise levels. All right, number 13, I'm going to look at it again. And again, when I multiply 4 and 3, I get 12. And so I have to ask myself, are there any combinations of 12 that will add up to negative 3? So I have 3 and 4, nope. 2 and 6, nope. 1 and 12, nope. Sorry, once again, no combinations that will add up to the middle term. So who are you going to call on? You're going to call on the quadratic formula once again. It's in standard form, so now I can define A, B, and C. A equals 4, B equals negative 3, and C equals positive 3. And then when I plug it into this same template right here, I'm going to have negative b. Well, once again, b is already negative, so it converts to a positive. And b squared again is 9 minus 4 times 4, 4ac, times 3. And this is going to be all over 2 times a, which is going to be 8. All right, now as I look underneath that radical sign, I'm going to notice that I only have 1 negative. So I get a feeling that I'm going to have an imaginary root here. Let's do this. 9 minus 12 times 4 or 16 times 3 is 48. So 9 minus 48 is going to equal negative 39. And this is all over 8. All right, there's not a perfect square embedded in the negative 39, so I'm going to leave it plus and minus. I'm going to just make that an I. Square root of 39 over 8. Keep in mind, this is 2 answers. It's 3 plus I square root of 39 and 3 minus I square root of 39 over 8. All right, moving on. Last 2 questions in this video. Okay, continuing the solving. Well, what do I notice on this first one is I see a GCF. Inspect it, folks. Do a good job at inspecting it. Don't know if it can be factored. You know what? This one is asking you to use the discriminant, or find the discriminant. Sorry, I don't have my review in front of me. And state the number of solutions. Okay, on the quiz, y'all are using the radical sign. What defines the discriminant is just the part underneath the radical, but it doesn't include the radical. So quit putting the radical sign over your answers. Sorry, I had to be forceful. All right, so let's define B. And well, let's just define A, B, and C. A is 6. B is 4 and C is 2. And when I plug it into this template, I'm going to get 16 minus 4. Sorry, that's a negative 2. 16 minus 4, A, C. Oh, I've got two negatives again. Well, that's going to convert that to a positive. So this is going to be 16 plus 48. And that's going to equal 64. Well, guess what? When your number is positive, if you're describing the roots, again, what are the roots? They're the zeros. And they're positive. That means you have two real number solutions. And we're going to leave it at that. There are two real number solutions. They're actually rational because 64 is a perfect square, but as far as I'm concerned right now, for the purposes that we're using today, we're just going to leave it two reals. If that came out a negative, it'd be two imaginaries. If it came out 0, there'd only be one real because the 0 would be touching just one time at the x-axis. Okay, let's move on. How to complete the square? Well, there's a couple ways you can do this. I like to show you the visual representation of this because completing the square is exactly that in algebra. It's actually making a perfect square. Well, a square is equal on all sides. So if we use a little box here, we're going to put x squared. We're going to split this in half because it's a perfect square. So it's got to have equal pieces. All right? We're looking for this number here. It's called completing the square. So if I factor out the GCF in this column, I get, or in this row, in this row, not column, I get x minus 2. When I do the same thing on this row, I get x, and really, this is going to be minus 2 because these two sides have to be equal. All right, x times x gives me x squared. X times negative 2 gives me negative 2x. Negative 2 times x gives me negative 2x. Negative 2 times negative 2, this is the missing number, is 4. Now obviously there's a shorter way of doing this, but I wanted you to understand why it's called completing the square. Take half of b, which will be negative 2, and then just square it, and you'll get your answer that goes in the box. Ladies and gentlemen, that concludes the second video.